revise what we studied yesterday. We just took one example of a rod. Okay, I'm just showing it in different way. This is one rod. Okay, you can take this as a rod like this, and it is subjected to which force? Tensile force. Okay, this rod is subjected to tensile force. We denote tensile force by P, capital P. Okay, let the cross sectional area of this particular bar is A, cross sectional area. So if I cut this, the cross sectional area is A. If this particular rod has diameter D, what is the diameter of the rod? Diameter D. Then area will be, area of the rod will be pi by 4 d square. Right? This is cross section. Area means which area? Cross sectional area. Okay, cross sectional area will be pi by 4 d square. Okay. Then we studied the concept of stress. How do you denote stress? Sigma. Stress is denoted by letter sigma. Okay, sigma is equal to. Now, whenever force is applied on this rod, what happens? The material of the rod resists. Okay, it resists that force. Okay, so there is internal resistance. So stress is actually internal resistance set up in the rod divided by area. But which area? Cross sectional area. Okay, but in practice it is observed that this internal resistance is always equal to external force. Internal resistance is equal to external force. That's why we write stress as external force upon area. So P by A is the simple definition of stress. Have you understood? So stress is force upon area. So simple. Force divided by area. So in this case, for circular rod, the force is P. Area will be pi by 4 d square. So by using this equation, we can calculate stress. Have you understood? Unit of stress is? Unit of stress will be unit of force divided by unit of area. What is unit of force? Unit of force is Newton, and that of area is meter square or millimeter square. Okay, generally mechanical elements are very small in dimensions. That's why that area is specified in millimeter square. So Newton per millimeter square or Newton per meter square is the area unit of stress. Have you understood? So stress unit is Newton per millimeter square. Also we studied that 1 Newton per millimeter square is equal to 1 megapascal. Right? 1 Newton per millimeter square is equal to 1 MPa. In short, it is called as megapascal. Okay? Now when this rod is subjected to tensile load, what happens? Now if I go on applying load, length of the rod will increase. Yes or no? If a force is applied on the rod, its length will increase. Okay, let that change in length is delta L. Very small change, very small change. Okay, that small change I denote by delta L. And original length of the rod is L. Okay, so we studied second concept, that was strain. What is strain? Change in length upon original length. So in simple words, it is delta L upon L. Delta L by L is called as strain. Delta L is change in length. Change in length will be either in meter or millimeter. Okay, so I can take, if it is in meter, divided by original length. Also in meter, meter cancels. There is no unit. So strain is unitless. Okay, strain has no unit. Is it understood? Okay, so it is millimeter, or meter, whatever it is, but strain has no unit. So we have studied these two concepts yesterday. Now we'll go ahead with the other concepts. Let us go ahead. Next we take Hooke's law. Okay, yesterday I had shown you the contents. So next one is Hooke's law. Just write down the definition first. Within elastic limit, stress is directly proportional stress is directly proportional to strain. Within elastic limit, stress is directly proportional to strain. So mathematically I can write within elastic limit. We denote stress by sigma, directly proportional to strain. Strain का notation क्या है? Epsilon. Okay, here I have epsilon is notation of strain. So stress is directly proportional to strain. Now if we introduce equality sign, there should be some constant. Whenever we replace proportionality sign by equality sign, so that constant we denote by capital E into epsilon, where capital E is modulus of elasticity. Modulus of elasticity, or it is also called as Young's modulus. Modulus of elasticity or Young's modulus. Okay, there are three elastic constants. Yesterday we saw the contents. This is the first elastic constant. This is called as elastic constant. Okay, so Young's modulus. Now let us derive unit of Young's modulus, so that I can write E is equal to, how can we write E is equal to? Stress divided by strain. Stress upon strain. So simple mathematics. What is unit of stress? Newton per meter square. Unit of strain? No unit. So what is unit of Young's modulus? Newton per meter square. Okay, so unit of SI unit of Young's modulus is Newton per meter square. Okay. Further, if we take this equation, E is equal to, what is formula of stress? Force upon area. So I am writing force upon area. Formula of strain divided by delta L upon L. Right? I just put the equations of stress and strain. So I just want to derive equation of delta L, change in length. So just take this delta L by L to LHS. So delta L by L is equal to, what will you get? P upon A E. Are you understand or not? Yes. If I take delta L to this side, and finally I get delta L is equal to P into L upon A E. So this is a very important equation to calculate change in length. Is it understood?
Yes.
By using this equation we can calculate change in length or deformation produced. Yes. It's already 1:30. I'll mark you absent today. You can sit. Close the door properly. Hello. Delta L is equal to PL upon A. Okay. By using this equation, we can calculate change in length. Or deformation. What is the other word to the change in length? Deformation. Change in length is also called as deformation. Okay. So in the numerical it may be mentioned, calculate deformation in the rod or deformation in the bar. So what is deformation? Deformation is nothing but change in length. Okay. So we have understood up to stress, strain, and finally change in length. Just draw this simple sketch. Load P acting on the rod. If I pull this rod, okay, this is one rod. If I pull this on both the sides, its length will increase. What will happen to the other dimension? You understood my question?
Yes, sir.
If I pull this rod on both the sides, length will increase. That means dimension along the axis will increase. What about dimension perpendicular to the axis? It will decrease. Yes or no?
Yes.
If it is circular rod, initially, if diameter is d, for example, this is diameter of the rod, and if I go on pulling it, इसका diameter reduce होगा कि नहीं?
Yes, sir.
Length increase होगी, but diameter will reduce. Okay, so this is the dimension which is perpendicular. This is dimension along the length. This is dimension perpendicular to the length. Yes or no?
Yes, sir.
This dimension is perpendicular to
Length.
length. Okay. Now whenever I say strain, what is strain? Change in length upon original length. Okay. But this strain, this change in dimension, is along the linear axis. I am calling this as linear axis. That's why this is called as linear strain. You understood? More specifically, I call this as linear strain. Now there is change in diameter also. Are you understanding or not?
Yes, sir.
यहाँ पर लेंथ चेंज हो रही है, लेकिन इसके साथ साथ diameter क्या हो रहा है? That is also decreasing. Okay, so other dimension is also changing. Are you understanding me?
Yes.
One dimension is increasing, other dimension is decreasing. Okay, so that strain is called as lateral strain. Have you understood linear strain, lateral strain? Now which dimension is changing? Diameter is changing. That's why I can write this as change in diameter upon original diameter. Have you understood the concept? Linear strain and lateral strain. Linear क्यों? Because the dimension is changing along the linear axis. Okay? While diameter is also changing along the lateral axis. Linear को जो perpendicular है उसको क्या बोलते हैं? Lateral. Linear and lateral. Is it clear? So lateral strain is delta D upon capital D. Right now. Linear strain, change in length upon original length. Lateral strain, change in diameter upon original diameter. Okay, now here, increase in length is taken as positive. What I am saying is, increase is taken as positive. Length increase हो रही है, decrease हो रही है? Length is increasing. Okay, so increase is taken as positive. What happens to the diameter? Diameter is decreasing. That's why while writing, as far as sign convention is concerned, इसको denote करते हैं epsilon capital L. Linear strain is denoted by epsilon capital L. Okay, while the other, that is lateral, is denoted by epsilon small l. A sign convention. Epsilon sign small l, that is lateral strain, because diameter is decreasing, I write negative sign with that. Have you understood this? Why negative? Because we take increase as positive, so decrease will be taken as negative. यहाँ पर diameter decrease हो रहा है. That's why while writing this equation, it is associated with negative sign. Is it clear? Now next concept is Poisson's ratio. Poisson's ratio. It is the ratio of lateral strain to linear strain. Lateral strain to the linear strain. Therefore, now it is denoted by mu. Notation is mu is equal to lateral strain epsilon small l divided by epsilon capital L. But you can see epsilon small l is minus delta d upon d. That's why I can write this as minus epsilon small l upon capital L. Or simply I can write minus mu is equal to epsilon small l upon epsilon capital L. Okay, this was the first elastic constant, which was what was the first elastic constant? Young's modulus E. Okay, now second one, right now. Second elastic constant, bulk modulus. Bulk modulus, it is denoted by K. It is the ratio of stress to the volumetric strain. Ratio of stress to volumetric strain. K is equal to stress will denote by sigma, which is P upon A. Okay, volumetric strain. Now just like, can someone define volumetric strain? Delta V upon P. Volumetric मतलब change in volume upon original volume. Okay, just like अगर लेंथ के लिए हम स्ट्रेन लेते हैं तो चेंज इन लेंथ अपॉन ओरिजिनल लेंथ, डायमीटर के लिए लेते हैं तो चेंज इन डायमीटर अपॉन ओरिजिनल डायमीटर. सो वॉल्यूम के लिए लेंगे तो चेंज इन वॉल्यूम अपॉन ओरिजिनल वॉल्यूम. इज इट क्लियर? सिग्मा अपॉन डेल्टा V डिवाइडेड बाय V. Okay, so what will be the unit? Let us derive unit. How to derive unit? Unit of stress divided by unit of this. Yes. Change in volume upon original volume. Unit or no unit? No unit. Change in volume meter cube. Original volume meter cube. Meter cube cancel हो गया. Numerator का unit क्या है? Newton per meter square. So what is unit of K? SI unit of bulk modulus is SI unit of bulk modulus is Newton per square. मतलब दूसरा जो इलास्टिक कांस्टेंट है उसका भी यूनिट क्या है? न्यूटन पर मीटर स्क्वायर. व्हाट इज न्यूटन पर मीटर स्क्वायर? न्यूटन पर मीटर स्क्वायर is also called as Pascal. Okay, just like unit of pressure, unit of stress. Okay. So we have now understood the concept of bulk modulus. Okay. Okay, now third elastic constant is shear modulus. Shear modulus or modulus of rigidity. Shear modulus of rigidity. Now for this you just draw this simple sketch. What is this? Front view of this box. ये क्या है? ये बॉक्स है, इसका फ्रंट व्यू. And what is this? Force. How it is applied? It is applied on the surface. अब तक हमने जो force apply किया था वो cross section पे apply किया था, like this or like this. Now how this force is applied? It is applied on the surface. So tangential. The force is applied tangential to the surface. Okay, and this bottom face it is fixed. ये क्या किसका convention है? Fixed. That this surface is fixed. Okay, so now this is fixed like this, and I am pulling this surface. इसको मैं क्या कर रहा हूँ? ऐसे pull कर रहा हूँ. ये face fixed है. How will it get deformed? इसका deformation कैसे होगा? ये फेस फिक्स्ड है, मतलब ये जगह पे रहेगा, बराबर है. What will happen to this face? It will get pulled, deformed. कैसे deform होगा? Will it deform like this or not? Because this is fixed. Bottom face is fixed. We are only pulling this top surface by applying this force. It will get deformed like this. यहाँ पर जो deformation होगा वो ऐसे होगा. Have you understood? Now in this case, this type of force which acts tangential to the surface is called as shear force. इसको क्या बोलते हैं? Shear force. Okay? हाँ, if force is applied on the area, can you find out stress? Force is applied on the area. What is stress? Force divided by this area.
Yes.
Correct?
Yes.
Are you all understanding or not?
Yes.
मैंने इस सरफेस पे फोर्स अप्लाई किया, तो इस पे स्ट्रेस कितना इंड्यूस हुआ? ये फोर्स डिवाइडेड बाय दिस एरिया. अब मैं यहाँ पे फोर्स इस सरफेस पे अप्लाई कर रहा हूँ, तो कितना स्ट्रेस इंड्यूस होगा, या जो भी स्ट्रेस इंड्यूस होगा वो कैसे कैलकुलेट होगा? फोर्स अपॉन एरिया. ओके, बट as the force is shear force, the stress is called as shear stress. Have you understood the concept? Shear stress किसको बोलते हैं? When the force applied is tangential. Better we write down. When the force is applied tangential to the surface. Tangential to the surface, comma, the force is called as bolo, shear force. Okay, therefore next time shear stress is equal to that is shear force. That is shear stress is equal to shear force upon which area? Surface area. It is not cross sectional area. Cross sectional area कब होगा? जब ऐसे अप्लाई करूंगा तो ये क्रॉस सेक्शनल एरिया होगा. जब ऐसे अप्लाई करूंगा तो सरफेस एरिया. ओके, डिवाइडेड बाय सरफेस एरिया. Okay, notation wise it is same because shear force we are denoted by P. So that is equal to P divided by surface area. Let this surface area is A. So I am writing this as P by A. But this is not normal stress. Sigma, whenever I say sigma, sigma कौन सा stress होता है? Normal stress. Sigma is called as
normal stress.
normal stress. Normal क्यों बोलते हैं इसको? Why normal? Yesterday I told you the reason. Normal means when you apply force like this, the area is perpendicular to that force. Normal मतलब perpendicular. है कि नहीं? नॉर्मल किसे बोलते हैं हम? इसको जब परपेंडिकुलर टू दैट इज कॉल्ड एज नॉर्मल. सो स्ट्रेस इज इंड्यूस्ड ऑन दिस सरफेस, दैट्स व्हाई दैट स्ट्रेस इज कॉल्ड एज नॉर्मल. यहां पे स्ट्रेस कहां पे इंड्यूस हो रहा है? सरफेस पे. दैट फोर्स इज shear force. That why stress is shear stress. Is it clear?
Yes.
Normal stress is denoted by sigma, shear stress is denoted by tau. This data is called as tau. So tau is equal to P upon A. Shear stress is denoted by tau. I hope you are understanding this concept.
Yes, sir. Yes, sir.
हाँ. अब यहाँ पे डिफॉर्मेशन कौन सा है बोलो? जब इस रॉड को मैं पुल करता हूँ तो जब इसमें लेंथ चेंज होती है तो दिस इज कॉल्ड एज डिफॉर्मेशन. ये डिफॉर्मेशन है ना?
Yes.
यहाँ पे डिफॉर्मेशन क्या है? ये जो शेप में चेंज हुआ है ना, shape of this box has been changed.
Yes.
So that is deformation. And in this case, ये जो एंगल है, this angle, it is denoted by phi, and it is called as shear strain. So write down. You show this phi. And write it as here the deformation is in the form of shear strain. Therefore, shear strain is equal to phi. Okay. Now we can define shear modulus. Shear modulus. Next line. Shear modulus or modulus of rigidity is equal to Young's modulus क्या है? Ratio of Young's modulus is ratio of stress upon strain, or more specifically normal stress upon longitudinal strain. This is normal stress. This is longitudinal strain. Correct? वैसे shear strain, shear stress upon shear strain. It is equal to shear stress upon shear strain. Stress by strain, so simple. Stress upon strain. Shear है तो modulus, longitudinal है तो Young's, denoted by G. G is equal to shear stress upon shear strain, or in terms of notations, G is equal to tau upon phi. What is unit of tau? Tau is stress. स्ट्रेस का जो यूनिट है सब स्ट्रेस का वही होगा, न्यूटन पर मीटर स्क्वायर. यूनिट ऑफ फाई, यूनिट ऑफ फाई थीटा यूनिट होता है, थीटा इज रेडियन और डिग्री. इसको कोई डायमेंशन है क्या? रेडियन डिग्री हैज नो डायमेंशन. डायमेंशन पर समझते हैं ना आपको?
Oh.
रेडियन और डिग्री आर डायमेंशन लेस. ओके, सो व्हाट इज यूनिट ऑफ जी देन? न्यूटन पर मीटर स्क्वायर. डिनोमिनेटर जो उसका यूनिट नहीं है, इट इज डायमेंशन लेस और यूनिट लेस. सो यूनिट राइट ऑफ यूनिट ऑफ मॉड्यूलस ऑफ रिजिडिटी इज न्यूटन पर मीटर स्क्वायर. So we have studied all the three elastic constants. कौन से? Modulus of elasticity, bulk modulus, and now shear modulus और modulus of rigidity. तीनों का यूनिट क्या है? ऐसा यूनिट न्यूटन पर मीटर स्क्वायर. All elastic constants have same unit, न्यूटन पर मीटर. There is derivation for this. We will not go into the derivation. तीनों elastic constants का जो interrelation है, it is like this. Okay, so if you know any one and if you know value of mu, Poisson's ratio, you can calculate all the elastic constants. While solving numerical, this equation will be useful.